So remember last semester in Geometry A when we talked about those special right triangles, and there are two of them, and I'm going to make an attempt at drawing a couple of them here. And so we're going to first draw our 30, 60, 90 triangle. So that one looks something like this. Okay, again, it's not going to be perfect, but it's close. Okay, so that's our 90-degree angle. This will be our 30-degree angle. This would be our 60-degree angle. Okay, and we remember we found those ratios of the side lengths. So the side opposite of the 30 was going to have a ratio of 1. Okay, the side opposite of the 60 was going to have the ratio of radical 3, and the hypotenuse was always going to have that ratio of 2. Okay, and then we also had that 45, 45, 90 triangle, which again was a right isosceles triangle. So again, the side lengths are going to be the same, and then just going to connect the legs there. And again, that's as close as possible. So here's our right angle. Here's our 45 degrees and our 45 degrees. Remembering that, again, these sides are the same. This is a right isosceles triangle. Okay, and our legs had a ratio of 1 to 1, so they're always the same length. And by the Pythagorean theorem, we figured out that the hypotenuse was always going to have that ratio of radical 2, right? And so these are our two special right triangles. Now let me circle this in red and star this, because if you don't know this, you're going to have to learn it, okay? You're going to have to memorize this. Whatever you have to do to memorize this, it's going to be very, very important, okay? Now, when we look at, we're asked to write the cosine of 30 as a fraction. So we're looking for the cosine of 30 degrees. Okay, now remember the cosine of 30 degrees, we're going to look at that 30-degree vertex, okay? And we remember SOHCAHTOA. So this is going to be the adjacent over the hypotenuse, okay? So the cosine of 30 degrees, well, the adjacent here, again, connected to 30 degrees, the adjacent here is the radical 3. So the adjacent leg is radical 3, and the hypotenuse here is 2. Okay, so radical 3 over 2 is what we have here. Okay, so that is going to be our cosine of 30 degrees, and we represented that as a fraction. Okay, now let's go ahead and look at another example. Okay, I'm going to go through drawing these triangles yet again. It's that important. Okay, so I'll draw my 30, 60, 90 triangle. Okay, so here's my right angle. I know it doesn't look like it, but that's all right. So here's again 30 degrees, 60 degrees, and we obviously have our right angle there. And the ratios, the side opposite of the 30 is going to have the ratio of 1. The side opposite of the 60 is going to be radical 3. And the hypotenuse is going to be 2. Okay? And we will now look at our 45, 45, 90. So we're going to go, as close as we can get to the same, because this is a right isosceles triangle. Here's our right angle. We have 45 degrees, 45 degrees, and obviously, again, our 90-degree angle. So if these side lengths are the same, they're going to be a 1-to-1 ratio. And by the Pythagorean theorem, we figure out that the hypotenuse will be radical 2, or 1 times radical 2. Okay? And now again, remember this. You have to know this. Okay? There's no way around this. We need to memorize all of this information. Okay? Now we're looking for the tangent of 45 degrees. Well, remember, SOHCAHTOA. Okay, so again, the tangent of 45 degrees is going to be equal to the opposite over the adjacent. Okay, well, in this particular case, the opposite over the adjacent here is going to be 1. So let's look at 45 degrees, doesn't matter which one you choose. The opposite here is 1. The adjacent here is also 1. So 1 is going to be our final answer here. Okay, so pretty simple, but you can see that if you don't know your special right triangles, this is going to be quite difficult.